So good morning everyone and welcome to your channel Learn Data Science with Pranjal. So in this short video, I'll cover various algorithm and methodologies through which we can find the similarity. And these algorithms can be used when your data is already in numbers or when your data is in text format, basically in your string format, then also it can be used. And we will start with a very simple algorithm, that is your Euclidean distance, and then we will see how the same idea can be extrapolated to when your data is in a string format. And we would be using some fuzzy logics as well, which will give you the answers in probabilities as well, that what's the probability that the two strings match. And once we can do this thing, probably the users can extend this idea on their different use cases. For example, the same thing can be used for your product recommendation, for your product matching, or whether the two strings are an exact match or they are not exact match kind of thing. So let's get started. So I will cover various algorithms, but let's start with the first algorithm. That is I'll not say algorithm, but the first methodology, that is your Euclidean distance. So we already know that Euclidean distance is the shortest distance between any 2 points. So what I've done, in interest of saving the time, I have already written up certain piece of code. I have created 2 points. One is my point A and another is my point B. So if I find the Euclidean distance, so this is how I'll find the Euclidean distance. So Euclidean distance is the shortest distance, and the formula for over here is x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square if your data is in 3 dimension. So at over here you can see I have used the I have used the function which is present in your numpy, and just to showcase that my calculations are going correct at this cell, so 5 minus 4 whole square. So at cell number 3, what I have done, I have used the inbuilt function present in my numpy. But over here at cell number 5 and 6, if you see, we have done the manual calculation and I get the same answer. Okay. Moving forward to the next method, that is your cosine similarity. Advantage of cosine similarity over here is that in our cosine similarity, we get our answers between a 0 to 1. In Euclidean distance, the upper range was not defined. So if in cosine similarity, if the score comes out to be 0, it means two vectors are at 90 degree. And if the score comes out to be if the score comes out to be 1, it means the two vectors are overlapping. So 1 means when it is an exact match, and 0 is when there is no match. So if we want, we can find cosine similarity using directly functions present in our scalar. But in order to explain how cosine similarity works, I have taken a small use case. So let's consider that there are three people, person A, person B, and person C. And I have taken few credentials of them. So age, work experience, education, and let's say income in lakhs. So for person A is of age 35, his experience is 12, and education is he has done your graduation, and income is 14 lakhs. Same thing for person B and person C. And my requirement is I want to find which person is more similar to A. Is it B or is it C? So basically I want to find, is B more similar to A or is C more similar to A? So what I will do, I will find the cosine similarity between A and B and between A and C. And wherever I get the more score, that person would be more similar. So just to show how cosine similarity works, internally what I'm doing a dot product. So in dot product, what I'll do, I'll multiply the corresponding element. So dot product of A and B would be 35 into 37 plus 12 into 15 plus 16 into 18 plus 14 into 23. Similarly, I can find the dot product of A and C. Then what I'm doing, I'm finding the magnitude of A. Magnitude is nothing but distance from the origin. So 35 minus 0 whole square, 12 minus 0 whole square. So, and then I will find the magnitude of B and magnitude of C. So now if I find at cell number 14, I'm finding the cosine similarity of AB. So if you notice, cosine similarity of AB is 0.98 and cosine similarity of AC is 0.9866. So basically, since the similarity score for A and B is more, compared to A and C. So B is more similar to A. If you see this data, then it is very difficult to say which person is more similar to A. Is it B or C? Because, so for example, in terms of age, C is more similar, but on other parameters, probably B might be more similar. Okay? So in terms of work experience, A, B and C, they both are equidistant from A. Okay? So over here, what I have done the manual calculation so that people can understand how the cosine similarity is being found. Once understood, there is no need of doing the manual calculation. Let's use our functions already present. So I can find my dot product using np dot dot, and then I can directly find the cosine similarity. Otherwise, there is already one function present in our sklearn, that is our cosine similarity. We can directly import cosine similarity and pass our A and B. So this will also give us the cosine similarity. Okay. Now let's moving toward the third methodology, that is similarity using overlap coefficient. So basically, what I've done, I have created I have already written the documentation of overlap coefficient. What logic basically overlap coefficient uses. So directly using the formula and finding the similarity doesn't make sense till the time we know pros and cons of each and every methodology. So if you read it, it's a very simple thing. It's one of the simplest way to measure the similarity of the string. And the formula or the logic it uses, it len of A intersection B upon len of minimum A or B. So basically, we find the intersection between A and B, take the length of that intersection and divided by the length of A or B, whichever is less, where A and B are two different strings. Now, issue with overlap coefficient. So now this is the main part. So while finding your similarity using your overlap coefficient, anyone should keep this thing in mind. So when you get an answer as 100% match, it may not be 100% match, but you still get that answer 100% match. So we'll see it, we'll try to understand it with an example. So issue with lab coefficient is that if one of the string is subset of another, then also we will get the 100% match. If it is a subset also, then also we'll get a 100% match, where 0 indicates least similarity and 1 indicates the highest similarity. So for example, what I've done, I have taken two strings, and this is an example to show if a string match, and then B is strings match or not. This is just an example to show. So first of all, what I do, I convert everything into lowercase. So I convert my string A also to lowercase and B also into lowercase, because Python is case sensitive. And then we do a split. And same process is repeated on your string B. And then we find the intersection. So if we see that these words are common to A and B both. And now, then what I'm doing, I'm finding the length of A and length of B. So length of A is 10 and the length of B is 11. Since the length of A is less in this formula, in above formula, len min of A or B. So over here, I will divide it by the length of A. So I'll divide it by 10. So len A intersection B upon len B, and the similarity comes out to be 0.6. So over here, what I have done, I have done the manual calculation just to showcase how your algorithm or the calculation works. And the same thing I have done converted into a small user defined function. So this will take two strings as an input, and it will do everything. It will convert it into lowercase, it will split it, it will find the intersection, it will determine which one is lower, which one has the lesser length, and then it will find the. So if you notice, it gives me the same answer. Now let's try understanding one issue with this methodology. So over here, what I've done, I have taken two strings. This is an example to show if strings match even when the strings do not match and are quite different. This is example to show. So over here, just by seeing these two strings, I can say that these two strings are not an exact match, because the words which are present in A, all the words are not present in B. They are not present in B. So for example, the word different, coit, they are not present. The word strings, this is also not present in B. But if you notice, all the words present in B are present in A. So in a way, B is a subset of A, and that is where the drawback is. So now when I find the similarity, I get the answer as 1, even though they are not exact match, but you will still get answer as 1 because B, one string is the subset of another string. So when you are using this methodology, overlap coefficient, please keep this drawback in your mind and don't just make a decision that you have got 100% match. It may not be a match, but still you may get a answer that it's a exact match. Now, moving towards the fourth methodology, that is a JACCARD similarity. Again, a very popular methodology, and the formula over here is quite simple. It says A intersection B upon A union B. So basically, we will find the intersection of A and B and divided by the union of B. Now, so JACCARD similarity would be between 0 to 1. Higher the score, more is the similarity. So what I've done, I've quickly created one user def function, JACCARD similarity. So it takes two strings as the input, convert them into lowercase, split them, find the intersection, and then you can find the similarity. So at line number 32, you can see. So this is an example of just. So over here, if you notice, this JACCARD similarity overcomes the drawback of your the earlier methodology, that is your overlap coefficient. So if even if it is a subset, then also you can use it. It will not throw you the result of 1 because A union B would take care of it. So A union B would be a very big number and A intersection B would be a smaller number. So JACCARD similarity overcomes. Unlike, and same thing I have written over here also. Unlike overlap coefficient, JACCARD similarity contains total members present in the denominator, which in the way will consider the difference between both the sets. So the basic difference over here is the denominator. The numerator part is same, A intersection B. If you notice, the numerator part is same, A intersection B. But in overlap, we were dividing by the minimum of A or B. And over here, we are dividing by union of B. So that's the advantage of a JACCARD similarity. Now let's move towards the very interesting one, that is of fuzzy logic. So fuzzy model or the fuzzy sets are mathematical means of representing vagueness and imprecise information, hence a term fuzzy. So fuzzy means where the things or the calculations are not exact. You take it in the range and you take it in the probabilities. These models have capability of recognizing, representing, manipulating, interpreting, and using data information that are vague and lack certainty. Now, so over here, what I've done, so fuzzy wuzzy. So fuzzy wuzzy is a library like your pandas and numpy. And from that, what I've done, I have imported a function that is a partial ratio. Now, and then for our example, what I've done, uh, I have taken several cases. I have several records I have taken. So, for example, what is the similarity ratio between India Tech and INDEE? So, suppose so many a times when we scrap the data from the website, or let's say we are reading the data which a user has given a feedback on some portal. So we don't expect that every time the person would be using the proper spelling, or there might be some typo errors in your text data. So for example, the person should have written India, but by mistake, spelling has got changed. So a two extra E's got attached. Now, what is the similarity between India Tech and India E? Or what is the similarity between India Tech and India Tech? So we are getting the scores. So similarity between this and this is 86. Over here, the scores are between 0 to 100. 0 indicates least similarity and highest, and 100 indicates highest similarity. Okay. So for example, 1, 2, 3, 4. So for example, over here, if I say India Tech and India, so it says that similarity is kind of 100. Okay. So when we are doing a kind of matching where we see that there can be some kind of typo errors or the data is being uh, scrapped in the raw format and we expect that some mismatches can be there, then better is we use our fuzzy logic. And so for each scenario what I've done, you can get the scores. So for the first record, matching score is 86, or you can say there is 0.86 probability that these two strings India Tech and in India match. Okay. And there is 78% probability that India Tech and India EEE Tech matches. So that is how your fuzzy logic works. Now moving towards the last one, which is a very powerful method of matching the text data or your string data, and that is your get close matches. So it actually yields very powerful result, and even if the string is very long, no problem in that. So but the best way to understand over here is what I have done. I have taken a little use case. So for example, let me say, and this is kind of my the data which we have used in our official purposes, but obviously I have changed the name so that there is no issues even if the data is reused. So what I've done, I have taken some base brand and I have taken a competitor brand. So for example, let me say you want to match if the brand mentioned at one place, does it matches with the brand mentioned at another place? Because when you are scrapping the data from the online platform, the platforms which are selling the products, the the way the seller writes the brand might be different. So the seller A may write it in a different way and the seller B may write it in the different way. So first of all, let me explain the use case, what we am trying to do. So I have two columns. One is my base brand, another is my, let's say, competitors brand. Now, for example, let's say this is a brand. Is this brand present in column G? So the brand might be present in column G, but it may not be present with the exact name. So suppose if I do a search, so it may be present with exact name or it may not be present with the exact name. So for example, KOLE. Is this brand present in my, so this brand KOLE is not exactly present in competitor's brand, but it might be present with some another name. So for example, KOLE and KOL are, do they match? So by mistake, let's say someone has written KOL or by mistake someone has written KOLE. Now I want to find, does every brand, does every record in F, does it matches with G? And keep one thing in mind, it may not be exact spell. The spelling might be different, there might be extra spaces, there might be special characters, whatever and whatever, right? So for example, over here, if you say HALLS and over here, if you notice HALLS, but between L and S, there is a there is a apostrophe. So if you do a exact match, if you do Control C and if you try to find it out, if you do a Control F, so you may not be able to find it out. But using our get close matches, let's see how can we address this problem. Okay, so what I have done is, first of all, I have quickly read the file and then I'm performing some amount of data cleaning, converting them into lowercase and dropping these extra brackets which are present over there. So I've said regex equal to 2 and drop. So this is data cleaning part. I'm not discussing this thing. So you can directly understand. Simple code is there. So I am uh, removing the extra spaces, white spaces at the starting and at the end. And then this is how my data looks like. Now what I'm doing is I am creating a list of base brand. So what is brands? Brand is the name of my data frame and base brand is the name of my column, and same thing I do with my comp brand. Then what I do, I use my get close matches, and this is how I'm doing. So I'm taking one record from base brand and comparing with my comp brand. So I will take one record from my base brand and compare it in my entire whole list of competitors brand. And I have taken cutoff probability as 0.8. So it means if cutoff probability is 0.8, I consider it to be a I consider it to be a match. And then I am storing the matches in your corresponding match list. So now if you notice, if you go a bit down, you will say these are the corresponding matches. And then I am creating a data frame. So now if you notice, it has given me the matches. So if produce was this, then its corresponding match can be produced. It's not exact spelling, but it is taking the idea that this can be. So for KOL, the exact match can be something like this. Okay. So for example, if it is a Clean Aid was a brand, then Cleaner might also be a same brand, but by mistake someone has written a different spelling. Okay. And if I take some another example, so RAM Pro, if RAM Pro was one brand, RMOPRO is also a brand. Algorithm says that there is a 80% or more than 80% chance that it's a match, and these two might be same brand, but only thing is someone has written as RAMPRO and someone has written as RMOPRO. And now let's discuss one more methodology, which is which I cannot say that it's a which no name can be given to it, like your Euclidean distance or cosine. Over here, what we will do, we'll try to use some NLP methodologies. We'll try to create a TDM matrix, so term document matrix. So term document matrix concept wise, I'm not discussing. If you want, you can see my some earlier videos on TDM. So what I'm doing, I'm taking one use case. So for example, product name, model, features. So these are my credentials of each and every product. So my first product was iPhone, and it was iPhone 11. Feature was 64 GB RAM and whatever. Now I want to see whether my each product matches with some another product. So over here, and this is the most powerful way to find your similarity, because what I'll do, I will remove the stop words also, I can remove the punctuations also, and then I can do my uh, matching. Suppose what we want to do is product matching. If any given record matches with any other record in the data frame. So basically I want to see, does my first product, does it matches with any other product in my entire list. So first of all, what I am doing, I am creating my description, product name, product model, this thing. And after creating descriptions looks something like this. Then this time I am using my analytical library. I am importing my stop words. So this program I have already discussed in my earlier video. So I'll just quickly do a recap for anyone who is not familiar with this program. So what I'm doing, I'm removing the string punctuations and I'm removing the stop word. So then what I'm doing, I'm going to create a term document matrix. So after creating my term document matrix, my matrix looks something like this. And so now the data which was earlier in alphabets or in words has been converted into numbers. And once the data is in numbers, obviously we can quickly find the distance or we can find the similarity. Now what I'll do is, on this logic, I will use my cosine similarity. So the data was first converted into numbers and now I'll use the cosine similarity. So what I've done, I'm using DEF function cosine similarity and it will return me the dot product. So now I give a call to my function and this is how it runs. So now, for example, when I say similarity between my product 0 and product 1 is 0.799, which means similarity between my this product and this product is 79, which is your 80%. And if you notice, apart from iPhone and Apple, rest everything matches. So similarity seems to be quite high. And then if we go for another thing, similarity between 0 and 2 is this much, similarity between 0 and 5 is this much, 0 and 6 is this much. So you may notice that I am not getting the answer for 0 and 4, 0 and 3. And why? Because I have taken a cutoff. I have taken a cutoff of 0.5. So it will give me the answer only when the probability is more than 50%. And if you want, you can change the probabilities also. You can change it to 0.6, you can change it to 0.7 or whatever. So now using this thing, you can find the similarity of one record in each and every record. and then probably you can decide, okay, if this product, this one of my product or one entry, does it matches, or if it matches, then which one is the highest match and what is the probability. So this is the most powerful way which I like, and it can be directly used for your matching thing. So basically it will club your NLP also and your cosine similarity as well. So with this, basically we come to an end of our this short knowledge video. So I'll not say short; it has got extended to 25 minutes. But over here we have discussed 7 to 8 different methodologies to find our similarity. So with this, I'll end the session. Thank you everyone for joining.